You've got a bunch of meetings. Some of them clash. Your job: cancel the minimum number of meetings so that nobody has a conflict. That's LeetCode 435. And the trick? A greedy approach that's almost too simple. Let me show you. The problem? You are given an array of intervals. Each one has a start and end. Some of them overlap. Find the minimum number of intervals you need to remove so that the remaining ones have zero overlaps. Important detail: intervals that just touch at one point are fine. 1 to 2 and 2 to 3 not overlapping. 1 to 3 and 2 to 4 overlapping. Let's walk through it. Intervals are 1 to 2, 2 to 3, 3 to 4 and 1 to 3. First, sort by end time. Now we get 1 to 2, 2 to 3, 1 to 3, 3 to 4. Start with 1 to 2 as our previous. Next, 2 to 3. Start is 2, previous end is 2. Not less than, so no overlap. Keep it. Update previous to 2 to 3. Next, 1 to 3. Start is 1, previous end is 3. 1 is less than 3, overlap. Remove it. Don't update previous. Next, 3 to 4. Start is 3, previous end is 3. No overlap. Keep it. Total removed, 1. That's the answer. Here's the key insight. When two intervals overlap, which one should we remove? The one that ends later. Why? Because the longer interval blocks more future intervals. The shorter one finishes early, leaving room for more intervals after it. So we sort by end time. The interval that finishes earliest comes first. Then we greedily keep it and skip anything that conflicts. This is the classic activity selection problem from algorithms class. Why sort by end time and not start time? Look at this example. Intervals 1 to 100, 2 to 3, 4 to 5. If you sort by start, 1 to 100 comes first. You keep it. Now 2 to 3 overlaps, remove. 4 to 5 overlaps, remove. 2 removals. But if you sort by end, 2 to 3 comes first, then 4 to 5, then 1 to 100. Keep 2 to 3. Keep 4 to 5. Remove 1 to 100. Only one removal. Sorting by end time always gives you the minimum removals. Here's the approach. Step 1. Sort all intervals by their end time. Step 2. Take the first interval as your previous. Step 3. Loop through the rest. If the previous interval's end is greater than the current interval's start, overlap. Count a removal. But don't update previous, because previous already has the smaller end. That's the greedy choice. If no overlap, update previous to the current interval. Step 4. Return the count. That's it. One clever trick in this code. The answer starts at -1, not 0. Why? Because previous is set to the first interval. But the loop also starts from the first interval. So the very first comparison is previous versus itself. Previous end equals current start, that triggers the overlap condition. But it's not a real overlap, it's the same interval. So starting at -1 cancels out that one false count. Clean trick. First, the custom comparator. It takes two intervals and compares their end values, index 1. Returns true if A's end is less than B's end. This makes the sort function arrange intervals by end time in ascending order. So 1 to 3 comes before 3 to 4, which comes before 2 to 5. Shortest ending first. Here's the main function. First, handle edge case, empty array returns 0. Sort by end time using our comparator. Set previous to the first interval. Answer starts at -1, remember, to cancel the self-comparison. Now loop through every interval. If previous end is greater than current start, overlap. Increment the count. But we don't update previous. Why? Because previous already ends earlier. That's the greedy choice, keep the one that finishes first. If no overlap, update previous to the current interval. Finally, return the count. Dry run. Intervals 1 to 2, 2 to 3, 3 to 4, 1 to 3. After sorting by end 1 to 2, 2 to 3, 1 to 3, 3 to 4. Previous is 1 to 2. Answer is -1. First 1 to 2 versus 1 to 2. Previous end 2 is greater than start 1. Answer becomes 0. This is the false positive we expected. Next 2 to 3. Previous end 2 start 2. Not greater. No overlap. Previous becomes 2 to 3. Next 1 to 3. Previous end 3 start 1. Greater. Overlap. Answer becomes 1. Previous stays 2 to 3. Next 3 to 4. Previous end 3 start 3. Not greater. No overlap. Previous becomes 3 to 4. Return 1. Correct. Time complexity O of n log n. The sorting step dominates. The loop itself is O of n single pass. Space O of 1. We are using constant extra space. Just one previous variable and a counter. No extra arrays. Simple, efficient, and optimal. Remember this pattern. Whenever you need to minimize removals for overlapping intervals, sort by end time and greedily keep the shorter one. This is the activity selection problem, a classic greedy pattern. Same family as merge intervals, LeetCode 56, and insert interval, LeetCode 57. Master the sort bind trick, and this entire category of problems becomes straightforward. If this made the problem click, hit like and subscribe. Drop a comment which interval problem should I cover next. See you in the next one.